so our goal for today remains the same. We are still going to be solving equations by factoring. That's our goal for today. And we start with reviewing solving by grouping. So remember, this is where we started off. If you notice the steps over here, for this one, we start with the original problem. We put it in standard form. So by way of review, let me just go ahead and write this out. So 2x cubed plus 8x squared plus 4x plus 16 equals 0. Now, notice what I did. It says we're going to factor each half. So what do I mean by that? So factor each half. So I group each half like so. And this one here. And then what we do is consider, is there a number if we just consider this half right here, just the 2x cubed plus 8x squared. Is there a number that comes out? And the answer is yes, there is. 2x squared comes out, and an x plus 4 stays in. Now I do that exact same idea for this half. Is there a common factor, a GCF, that pulls out? And the answer is yes. What comes out? I'm bringing down this plus. I'm bringing down that plus. And it looks like I can pull out a 4, just a 4. And when I do that, I get x plus 4 all equal to 0 there. This was the part where you might say, I don't quite get it. Well, notice here that x plus 4 and x plus 4 are exactly the same. So I'm going to factor out the x plus 4 in its entirety. So I'm going to put x plus 4, effectively I'm doing this. I'm putting the x plus 4 in the front, and this 2x squared is going to combine with that 4 right there. All still equal to 0. And look, we just factored it. Now from here, zero product property. So I'm going to skip that part right now, and you can watch it in the video from yesterday if you'd like. All right, so solve this one by factoring. Okay, it's already in standard form, so that's a check. So eyes on deck to see the craziness that's going to happen here. When I put parentheses around this first one, there's no big deal. But notice this. When I put parentheses around here, I've created a problem for myself because I'm now saying that everything on the inside has to be taken the opposite of. I started with the negative 6, but if I distribute this negative in, it ends up with a positive 6. So this is the one caveat. Here's the one caveat. When you have a subtraction in the middle, the last operation has to change. So minus in the middle, this last one has to change, opposite. All right, so now from here, I'm going to group each half. So between these two terms, I see there's an x squared. So I'm going to put an x squared there. And when I factor that out, I get x plus 2. I'm going to bring down this minus right there. And notice what I can factor out in the next two terms. I can divide both of these by 3. So I put 3 on the outside. And notice an x plus 2 comes down. If this works, then these two will be the same. Conversely, if these aren't the same, then it won't work. It only works if the binomials or whatever they are exactly the same. So now I'm going to pull out the x plus 2. So x plus 2 I write on the left or in the front. And now the x minus the 3, x squared minus the 3 is going to be the other factor, equal to 0. Using the zero product property, the x plus 2 is 0, or the x squared minus 3 is 0. Solve here to get x equals 2. Solve here to get x squared equals 3. And when I simplify, I get plus or minus radical 3. So my three answers are negative 2, negative radical 3, and positive radical 3, my three solutions. We already know this idea. It's called the difference of squares. If I take a squared and subtract b squared, I know that this equals conjugates, a plus b, a minus b. So, for example, x squared minus 81 will always factor to x minus 9, x plus 9. Very quick and uncomplicated. The exact same idea happens, but instead of it being super simple like a binomial times a binomial, it ends up breaking up to a binomial times a trinomial. So the real skill here is, number one, can you recognize you have cubes? Like that's a perfect cube and that's a perfect cube. And second, can you put them in the right place? And that's it. It's about recognizing and placement, not necessarily math skills. It's identifying and putting them in the right place. Before we jump into this actual theorem or theory or whatever, let's refresh ourselves with what some cubes are. I'll start it off and you please finish it up. Some perfect cubes. So, in other words, 1 times 1 times 1 is 1. So 1 is a perfect square, the red number. 2 times 2 times 2 is 8. So 8 is a perfect square. And we can write that. You probably may not have seen this notation before. But if I said 8 with a small little 3 inside there, that means cube root. So once we have all of these at least thought about, what we're going to do is look for them and recognize them. So what we're going to do here is walk through one, and this is called the sum because of that plus there. The sum of cubes. Both of these are perfect cubes. So notice here, x cubed is already written as a cube, x cubed. 512 can be written as a cube, and that would be 8 cubed. Is that right? So I'll bring down the equal 0. So in other words, what we know here is that my a equals x and my b equals 8. So what I'm going to do is just take that x and the 8 and just substitute into the top one here. I put an 8 here, x here, 8 here. X, 8. X, 8, 8. All we do is direct substitution. So I'm going to rewrite this rule right here for us to use. So, rewriting it right here. So a plus b times a squared minus ab plus b squared. So I'll put equals. So that's us factoring it. So I'm going to substitute in the x and the 8 in the appropriate places. So x goes in the front, and then 8 comes next. Now x squared minus x again, and then the b is 8 plus 8 squared, end parenthesis. Now we just now we just simplify. So first we identified that these were perfect squares, and I rewrote them so I clearly saw what the cube roots were, the x and the 8. And then I just took the x and the 8 and substituted them in the right places. And now I'm going to simplify and then use the zero product property if possible. All right, so x plus 8 stays as is. This one here, x squared minus 8x plus 64. And then when we split, we get this equation here. That one's straightforward. And we get this equation here. This one's not as straightforward because it turns out there are no, and I forgot the equal 0. If I tried to factor the second one, I'm going to notice that there are no factors of 64 that add to a negative 8. There are no factors of 64 that add to a negative 8. So, it says each one of these we're going to solve, and we're going to specifically use our math skills. One of them, it's just linear, so all we have to do is add or subtract. The other one, we're going to use quadratic formula. Let's go ahead and do that real quick. So x equals negative 8. Yay! We got that one. Now over here, I'm going to, I'll just try using quadratic formula for now. So x equals negative b, so negative 8, plus or minus radical b squared, negative 8 squared, minus 4a is 1 and c is 64. The radical's got to go all the way across. And notice that when I make the fraction does not go under the x there. All over 2a. I'll pause. Now we simplify where we can. Double negative is positive. So 8 plus or minus 64 minus. So we've simplified. Now 8 plus or minus. Notice I'm getting a negative here. Negative 1, 9. Notice there's a negative in there, which means I'm going to have an I that comes out. And 192, I can just take a moment real quick to simplify that. It's 2 and 97, 96, sorry. And then 96 can be 12 and 8, 4, 3, 4, 2. Notice what can come out, not that one. A pair of 4s there and a pair of 2s there. So I get 8 radical 3. So now, I'm not going to forget my I, 8 plus or minus I times 8 radical 3, all divided by 2. And now I have to reduce. I can divide both the top terms by by 2. So I get 4 plus or minus 4i radical 3. And so notice here, since we end up with a complex answer, like I mentioned earlier, that this part here, if you have a complex number, that means with an I, then you will always have a plus or minus version of that. Notice it's not opposite, so that the front's not changed. It's in this case, the conjugate. But if you have a complex number as a solution, you will always have a plus or minus in front of that. Always, always, always. So here are my three answers. X is negative 8, or X is 4 plus or minus 4i radical 3. And now let's solve the next one here. So our first step is we're going to rewrite them as cubes. So 27x cubed is 3x all cubed, and the 1 is a perfect cube, so 1 cubed. Now I'm going to substitute, this is my a, so it becomes a minus my b, 3x minus 1. Then my a squared goes there, my a times b goes there, my b squared goes there. Now I'm going to simplify. This one stays the same. 3x squared becomes 9x squared. 3x times 1 is 3x, and 1 squared is 1. All of that equals 0, so the zero product property says that 3x minus 1 equals 0, so here's one solution. The other one's a little bit more complicated because I recognize that I can't really complete the square here, so I am going to have to use the quadratic formula. So x squared, x equals negative b plus or minus b squared minus 4ac all over 2 times a. Now I simplify, and inside I get negative 27. So I get 3, negative 3 plus or minus negative 27 over 18. Negative 27 simplifies. If you need to see that, it looks like this. And a 3 comes out, the negative comes out, and a 3 stays in. Now, when I take this fraction right here, negative 3/18, that reduces to negative 1/6. And when I take this 3/18, it reduces to 1 over 6. So the radical 3 stays there, and now I'm going to write the I in the end. So a little bit complicated, but still the answer.